In this lecture, we will learn about the abstract factory design pattern and how to implement it in Python. Abstract factory is a creational design pattern. It allows us to design a superfactory that creates other factories. With this pattern, we provide interfaces for creating families of related or dependent objects without specifying their concrete classes. We can say that the abstract factory is a factory of factories. Each generated factory can create the objects as per the factory design pattern, which we will learn about in a few lectures. When do we use the abstract factory design pattern? We use the pattern when our code needs to work with various families of related objects, but we don't want it to depend on the concrete classes of those objects. They might be unknown beforehand, or you simply want to allow for future extensibility. In a well-designed program, each class is responsible only for one thing. When a class deals with multiple object types, consider using the factory or abstract factory design patterns. To implement the abstract factory design pattern, we first map out the objects and variants of objects. Then we declare abstract object interfaces for all object types. We then make concrete object classes implement these interfaces. Next, declare the abstract factory interface with a set of creation methods for all abstract objects. Then we implement a set of concrete classes, one for each object variant. After that, we write the factory initialization code. Then anywhere we were going to call the product constructors, call the appropriate creation method on the factory instead. Let's look at the pros and cons of using the abstract factory design pattern. On a positive note, objects created by a factory are compatible with each other. It avoids tight coupling between concrete products and client code. Code using the abstract factory pattern follows the single responsibility principle, where each class does one thing and does it well. Using the abstract factory pattern, we can introduce new variants of existing objects without breaking existing code. The drawback of using the abstract factory design pattern is that the code may become overcomplicated with lots of new interfaces and classes. Let's learn how to implement the abstract factory design pattern in Python. We will create a class named Mobile. Inside of this class, we will define a getAndroidPhone function that takes in the self parameter. Inside of this function, we will use the pass keyword. Then we will create a function named getIOSPhone, which takes in the self parameter. We will use the pass keyword here as well. Now we will create a class named Samsung that extends the mobile class. Inside of this class, we will define a getAndroidPhone function that takes in the self parameter. Inside of this function, we will return a Samsung Galaxy object. Then we will implement the getIOSPhone function that takes in the self parameter. Inside of this function, we will return a Samsung Guru object. Next, we will create a class named Android. Inside of this class, we will define a function named getModelDetails that takes in the self parameter. Inside of this function, we will use the pass keyword. Then we will create a class named iOS that also defines a getModelDetails function, which takes in the self parameter. Again, we will use the pass keyword as a placeholder, so that any class that extends this class can implement its own version of it. Next, we will create a class named Samsung Galaxy that extends the Android class. Inside of this class, we will implement the getModelDetails function. Inside of this function, we will return model Samsung Galaxy, RAM 2GB, camera 13MP. Then we will create a class named Samsung Guru that extends the iOS class. Inside of this class, we will implement the getModelDetails function. Inside of this function, we will return the string model Samsung Guru, RAM NA, camera NA. Next, we will create a class named Mobile Client. Inside of this class, we will define the init function that will take in two parameters, self, and a parameter named mobile of type mobile. Inside of the init function, we will set self.AndroidPhone equal to mobile.getAndroidPhone and self.iOSPhone to mobile.getIOSPhone. Then we will define a function named getAndroidPhoneDetails that takes in the self parameter. Inside of this function, we will return self.AndroidPhone.getModelDetails. Then will come a function named getIOSPhoneDetails that takes in the self parameter. Inside of this function, we will return self.iOSPhone.getModelDetails. Time to test our code. We will create a variable named Samsung Mobile Phone and set it equal to a Samsung object. Then we will create a variable named Samsung Client and set it equal to a mobile client with Samsung Mobile Phone passed in. After that, we will print Samsung Client.getAndroidPhoneDetails and then have another print statement that prints Samsung Client.getIOSPhoneDetails. When we run the code, Notice that our abstract factory assembled the proper phones according to type and printed their details to the console. In the next lecture, we will learn about the builder design pattern and how to implement it in Python.